After we learned about light and plane mirror at the previous meeting, now we will learn the new part, which is curved mirror, cermin lengkung. Now we will learn about the feature of curved mirror, itu ciri-ciri dari cermin lengkung. In our daily life, we usually see several types of mirror, like shaving mirror, car driving mirrors, we usually call rear view mirror, and mirror reflectors of searchlight mirror that give reflection from surface which are curved. Such mirror is called curved mirror. Dalam kehidupan kita sehari-hari, kita sering melihat beberapa jenis cermin seperti cermin cukur, cermin yang ada di spion mobil, cermin pantul dari lampu sorot yang memberikan pantulan dari permukaan yang berbentuk lengkung. Cermin yang demikian disebut cermin lengkung. The kind of curved mirror we use are generally made by silvering, a piece of glass which would form part of the shell of a hollow sphere. Jenis dari cermin lengkung yang biasa kita gunakan dibuat dengan cara silvering daripada kaca yang akan membentuk bagian daripada kulit bola yang berongga. There are two types of spherical mirror. Is silvering the glass on the outer curved mirror is called concave mirror, cermin ceku, while silvering on the inner curved mirror is called convex mirror, cermin cembung. As you can see from the left figure below, if silvering the glass on the outer curved mirror, the mirror is called concave mirror. And on the right figure below, as you can see, the silvering of the glass is on the inner curved mirror. The mirror is called convex mirror. Before we learn more about spherical mirror, we will learn first about the part of spherical mirror. The first part is principal axis. Principal axis of spherical mirror is the line joining between center of mirror, point P, and the center of curvature or center of spherical, point C. So, principal axis of spherical mirror is PC. Distance PC is called radius with symbol R. And the second part is focus F. When a parallel beam falls on plane mirror, it will be reflected as parallel beam. But in the case of concave mirror, when parallel beam of rays that parallel with principal axis falls on a concave mirror will be reflected converge to one point. This point is called principal focus, or we can say real principal focus. And in the case of convex mirror, when parallel beam that parallel with principal axis falls on convex mirror, The rays will be reflected as if the rays comes from one point behind the mirror. This point is virtual principal focus, and the distance between point P and F is called focal length F. After we know the part of the curved mirror, now we will learn about the relation between the focal length and the radius of curvature spherical mirror. First, we have to look the right figure. At the right figure, incident ray AB parallel and close with principal axis PC. The reflected ray pass through focus. By the geometry, radius BC is perpendicular to the tangent to the curve at P. Hence, BC is normal to the curve surface at point B. Thus, angle ABC equals angle CBF, Snell's law. Angle ABC equals angle BCF, alternate angle. Because of that, angle CBF equals angle BCF. Hence, triangle PFC is isosceles. BF equals FC. Since AB is parallel and close to principal axis, so BF equals PF and PF equals FC. From this we can get F equals half R. And by using the same process like on concave mirror, we can get similar relation between F and R on convex mirror. That F equals half R2. Before we learn about the image formation on concave mirror and convex mirror, first we will learn about the types of image. There are two types of image in here. The first image is real image. This image is located in front of the mirror. This image is created by the intersection of two or more reflected rays. This image can't be seen by our eyes. It just can be seen on the screen. Or we can say this image catch by the screen. Bayangan nyata adalah bayangan yang terletak di depan cermin. Bayangan ini dibentuk dari perpotongan dua buah sinar pantul. Bayangan ini tidak dapat dilihat langsung oleh mata kita, hanya bisa dilihat melalui layar. And the second image is virtual image. Virtual image, this image is always located behind the mirror. And this image is created by the intersection of two or more extended reflected rays. This image can be seen by our eyes. Before we learn about the image formation on concave and convex mirror, first we should know the ray tracers on the two types of mirror. Now we will learn about the ray traces on concave mirror. There are three ray traces on concave mirror. The first, the ray that comes parallel to principal axis will be reflected through point F or through focal point. The second, the ray that comes through point F will be reflected parallel with principal axis. The third ray is the ray that comes from point C or center curvature of mirror will be reflected back through point C. Now we will learn about the image formation on concave mirror. But before that, we have to realize that image can create it if the ray come from the object. The same with plane mirror. In image formation on concave mirror, we needed minimum two ray traces on concave mirror. There are 5 position objects AB in front of concave mirror we will learn in here. The first position, object located beyond C. As we can see from the figure, from object AB, the first ray comes parallel with principal axis and will be reflected through point F. And the third ray that comes to point C will be reflected through point C too. But in here, we can see the two reflected rays is intersect A accent, B accent. The image is inverted. As you can see, the red arrow inverted. This image is called real image. So in here, we can get the properties of image is real because created in front of the mirror, inverted, and diminish. The second position is object located at point C. From the figure, we can see that from the object, the first ray comes parallel with principal axis and will be reflected through point F. And the second ray, the ray comes through point F and reflected parallel with principal axis. And in here, we can see that the two reflected rays intersect A accent, B accent, as shown by red arrows. Because the image is created by intersection by two reflected rays, this image is real image because located in front of the mirror. And the image is inverted. And as we can see, the size of image is the same with the size of object. The third location of object is object located between point F and point C. As you can see from the figure below, from object AB, the first ray comes parallel to principal axis, and then the ray will be reflected through point F. Because we can use the second ray, so we can use the third ray. The ray that comes from point C will be reflected through point C2. And in here, we can see the two reflected rays intersect at A accent and B accent. And as you can see, the image created is inverted. And because the location of image in front of the mirror, the properties of image is real, inverted, and the size of image is bigger than the object, so we can say magnified. So image properties is real, inverted, and magnified. The fourth position object AB is object located between point F and point P. From the object, the first ray comes parallel to principal axis and then reflected through point F. And the third ray that comes from point C will be reflected to point C2. From the figure we can see that the two reflected rays does not intersect one to each other. Because of that, from the two reflected rays is extended behind the mirror. In here we can see that the two extended reflected rays intersect behind the mirror. Because of that, the image is created behind the mirror. This image is called virtual image. And because the size is bigger, the property is magnified. And the image is upright. So the image properties in this position is virtual, upright, and magnified. The fifth position of object AB located at point F. As you can see from the figure, the first ray that comes parallel to principal axis will be reflected to point F, and the third ray, the ray that comes from point C, will be reflected through point C2. Because two reflected rays is parallel, in here we can say there are no intersection of reflected rays and no intersection between two extended rays. So in this position, if the object located at point F, there is no image created in here. After we have learned about the image formation on concave mirror, we should know the application of the concave mirror. The application is first for dentist mirror, the second saving mirror, the third is reflector mirror on searchlight, reflector mirror on headlight vehicles, and reflector mirror on flashlight. To understand more about the image properties on concave mirror, we can use the room rules on concave mirror. To understand about the room rules, first we should know the location of the room. The room 1 located between point P and point F, and the location of room 2 located between point C and point F, and location of room 2.5 located at point C, and the location of room 3 beyond point C, and the last location of the room 4 located behind the mirror. In this rule, room object plus room image equals 5. By using this rule, we can predict image properties created on concave mirror based on the object location and image location. As you can see from the table below, if the object located at room 1, the image will located at room 4. Because the image located at room 4 behind the mirror, so the image must be virtual.
and the virtual must be upright. And because the room image bigger than room object, so the image must be magnified. So the image properties is virtual, upright, and magnified. And if the object located at room 2, the image located at room 3. Because the located image is in room 3 in front of the mirror, so the image must be real, and the real must be inverted. And because the room image bigger than room object, so the image must be magnified. So the image property is real, inverted, and magnified. And if the room object at room 3 and image located at room 2, because the image located at room 2 in front of the mirror, the image must be real and the real must be inverted. And because room image is smaller than room object, so the image must be diminished. So the image properties is real, inverted, and diminished. And if object located at room 2.5, the room image will be 2.52. Because the image located at room 2.5 in front of the mirror, the image must be real. The real must be inverted. And because the room image equals with the room object, so the image must be the same size. So the image properties is real, inverted, and same size. After we learn about the concave mirror, now we learn about the convex mirror. Before that, we should know the ray traces on convex mirror. There are three ray traces on convex mirror. The first ray is the ray that comes parallel to the principal axis will be reflected as if the ray comes from the focal point of the mirror or from the focus of the mirror. The second ray, the ray that comes toward the point F, will be refracted parallel with principal axis. The third ray is the ray that comes toward point C, or center curvature of mirror, will be reflected as if the ray comes from point C. After we know about the ray traces on convex mirror, now we will learn about image formation on convex mirror. While we learn about image formation on convex mirror, first we should realize that the object always located in front of the mirror. And as you can see from the figure, there are two rays that comes to the mirror. The first ray is the ray that comes parallel to the principal axis will be reflected as if the rays come from focal point of mirror. And the third ray that comes from the object comes toward the point C or center curvature of mirror will be reflected as if the ray comes from point C. As you can see, the two reflected rays doesn't intersect one to each other. Because of that, from the two reflected rays will be extended using the dash line behind the mirror. The dash line will intersect in one point. So the image will be created at the point of intersection, as shown by red arrow. Because the image created by the intersection of two extended reflected rays behind the mirror, the image must be virtual. The virtual always upright, and from the size of image, we can know that the image is diminished if compared with the object size. After we learn about image formation on convex mirror, which is just location, where the object just located in front of the mirror. Now we will learn the application of convex mirror. There are three applications of convex mirror in here. First is blind corner mirror. Ini yang sering kita sebut sebagai kaca yang berada di tikungan jalan. And the second is supermarket mirror. The function of supermarket mirrors for security purpose, so that the employee can see the corner of supermarket. And the last application is rear view mirror. This is we know as kaca spion. After we learn about the image formation and image properties on convex mirror and concave mirror, now we will learn about the formula for the two mirrors. And here we see there are three formulas. The first formula is super F equals super SO plus super SE, where F is focal length and SO is distance object to mirror, and SI is distance image to the mirror. The second formula is M equals SI per SO in absolute mark, and M equals HI per HO. In here, M is magnification, and HI is image height, and HO is object height. And the third formula, as we know at the previous slide, relation between F and R, F equals half R. In using formula for the two mirrors, we should know the agreement. There are several agreements in here. First, focal length. Focal length will be positive for converging mirror or concave mirror. Focal length will be negative for diverging mirror or convex mirror. SO is distant object to the mirror will positive if object located in front of the mirror, and SI distance image to the mirror will positive if image located in front of the mirror. This image is real image, and SI will be negative if image located behind the mirror. This image is virtual image, and HO is object height and HI is image height. Now we'll see the example for the problems. The first, an object which has height 4 cm is placed 6 cm in front of concave mirror, which has radius curvature of mirror 8 cm. Determine A. Image distance, B. Image magnification, C. Image properties, D. Image height. In here, given R equals 8 cm, positive because this is concave mirror. Because of that, the focus will be 4 cm, positive 2. Remember, concave mirror, then convergent mirror. And SO, the location of object, because in front of the mirror, so the SO equals 6 cm. And from the problem, they ask about SI, M, magnification, HI, and image properties. Now we will answer question A, image distance SI, because at the problem they give for information F and SO. So using formula 1 per F equals 1 per SO plus 1 per SI. So 1 per 4 centimeters equals 1 per 6 centimeter plus SI. Thus of that, S per SI equals 1 per 4 centimeters minus 1 per 6 centimeter. So S per SI equals 3 per 12 centimeters minus 2 per 12 centimeter. S per SI equals 1 per 12 centimeter. In here, we can get SI equals 12 centimeter. Because 12 centimeter is positive, because SI is positive 12 centimeter, so we can say the image is real because SI positive and the real must be inverted. For question B, the problems ask about image magnification M. From the formula above, magnification M equals SI per SO in absolute mark. So M equals 12 centimeter per 6 centimeter. So the magnification is 2 times. For question C, the answer for question C, as we know from the point A, answer from point A, we know that SI is positive, so the image is real. Real must be inverted. And from question B, the answer question B, the magnification is 2 times. So the image is magnified. So in point C, we can answer image properties is real, inverted, and magnified. For question D, image H, HI, using formula M equals HI to HO, 2 equals HI per 4 centimeter, we can get HI equals 8 centimeter. Example number 2. An object is placed 4 cm in front of concave mirror which has radius curvature of mirror 12 cm. Determine A. Image distance SI, B. Image magnification M, and C. Image properties. From the problems given are positive 12 cm because the mirror is concave mirror. Because of that, the focal length equals half R equals 6 centimeter. And because object is placed 4 centimeter in front of the mirror, so SO is positive 4 centimeter. The problems ask SI for A, B, M, and C image properties. For question A, image distance SI, and from the problems given F 6 centimeter and SO 4 centimeter. Using formula 1 per F equals 1 per SO and plus 1 per SI, we can get 1 per 6 centimeter equals 1 per 4 centimeter plus 1 per SI. So 1 per SI equals 1 per 6 centimeter minus 1 per 4 centimeter. And 1 per SI equals 2 per 12 centimeter minus 3 per 12 centimeter. So 1 per SI equals minus 1 per 12 centimeter. So in here we get SI equals minus 12 centimeter. Because SI has minus value, in here we can say the image is virtual. And because the image is virtual, the image must be upright. For question B, the problem asks image magnification M, and M equals SI per SO in absolute mark. Because of that, M equals minus 12 centimeter per 4 centimeter in absolute mark. So the magnification is 3 times. Because 3 times, the image is magnified. For question C, image properties from the answer question A and question B, we can get the image properties is virtual, upright, and magnified. Now we'll see the third problems. An object is placed 30 cm in front of convex mirror. If distance image to the mirror is 10 cm, determine A. Focal length of the mirror, B. Image magnification, C. Image properties. From the problem is given Si equals minus 10 cm. The value minus for this problem because the mirror is convex mirror. For convex mirror, the image always behind the mirror. Because of that, the mirror produces virtual image. Because of that, Si equals minus 10 centimeter. And because object is placed 30 centimeter in front of the mirror, so So equals 30 centimeter. And from the problems, as F, M, and image properties. For the question A, from the information for the problems given, Si equals minus 10 centimeter, So equals 30 centimeter. So to determine F, we can use formula 1 per F equals 1 per So plus 1 per Si. So 1 per F equals 1 per 30 centimeter minus 1 per 10 centimeter. So 1 per F equals 1 per 30 centimeter minus 3 per 30 centimeters equals minus 2 per 30 centimeter. And here we can get the focal length equals minus 15 centimeter. This is suitable for the convex mirror as negative value for the focus. For question B, image magnification M equals Si per So in absolute mark. So M equals minus 10 centimeter per 30 centimeter in absolute mark. So we can get now the magnification M equals 1 per 3. For answer C, image properties based on the problem because Si is negative 10 centimeter. In here we can conclude the image is virtual and the virtual must be upright. And from the answer point B, because the magnification is 1 per 3, so in here we know the magnification 1 per 3 is diminished. So we can say the image properties is virtual, upright, and diminished.